In this video, we're going to start a discussion about outliers. Outliers can be one of two things specifically. First, they can be cases that differ dramatically from the rest of the data. So, for example, if you're studying the heights of students at the University of Delaware, outliers would be cases where a person is extremely tall, so tall that they are kind of much taller than the next tallest person. Or potentially outliers in that situation could be people who are very short, people who are so short that they are much shorter than the next tallest person. So things or observations rather that are just very far from the center and very far from other observations. And the second sort of possibility for outliers is outliers are things that don't make sense in the context of the problem. So just things that we might not be interested in. And I know that that's a very amorphous definition, but you'll see an example of both of these things coming up shortly. So a question you might ask is, should we care about these unusual situations? Do I care about if I'm studying the heights of University of Delaware students, what if there's one person who's 7.5 feet tall? Do I care about understanding that single person if I'm really most interested in the trend of heights? How tall are students at the University of Delaware? Well, there's this really one tall person that's going to skew our average. Should I care about this? Well, the truth is that it can, including outliers, can affect estimation. So we really do want to know, how our estimation will be affected. What do I mean by our estimation will be affected? Let me give you an example. So here's a graph. And let's say I have some dots. Okay, these are the data points. And ordinarily a line would look so let's add some dots here. Maybe a line through these dots is drawn here. Well, now if I add in a point that's way down here, what I want you to understand is that the line of best fit might look more like this. So that one dot is going to be calculated into the average. It's going to drag the line toward it slightly. And the more outliers you have, the more the line will be dragged. You see what I mean? So outliers will pull the line toward them. It might be subtle if there's only one, but the more unusual situations you have, the more likely it is that the estimation will change. Okay, so back to our slides without the drawing. Since outliers are by definition unusual, we're not going to be very good at making predictions about them. The point of creating our statistical models is to predict typical cases, to understand what is most likely to come next, not to know whether there's a 7.5 foot tall student this year at the University of Delaware when maybe there hasn't been a student of that height for many, many years. We aren't trying to predict unusual things. We're trying to predict general fluctuations from predictor variables. So we can identify outliers visually by looking at a histogram or a scatter plot for both y variables and x's. So if we think about a linear regression model, the response, say donation amount, could have extreme values. We could have $1 million donations. Are we going to have lots of them? Depends on the organization, but probably they're not super common. When it comes to the x variables, let's say we're looking at ages and incomes, surely there can be outliers there too. So it's important for us to check everywhere for these situations. We're going to illustrate outliers based on a linear regression model, but they can exist in any type of model. Logistic regression models can contain outliers too. When we look at the response, a 1 or 0, say yes, we get a donation, or no, that can only be ones and zeros, so there aren't going to be outliers there. But outliers can exist in the X variables for a logistic regression. So it is important to consider this before we start modeling.